Well, let me focus. I hate that I gotta do this every time. No, my camera does not have autofocus, so just won't let it rock. Fix up my lighting. There we go. That's better. Get a little bit of a crispier image now. How do I sound? How am I sounding, baby? Okay. Well, I've got green signal on my microphone feedback. So I'm going to go ahead and proceed. Welcome back to Silicone Made Simple. It is Thursday night, and we are doing another beginner-friendly tech YouTube live stream. So this is a channel where we basically practice cybersecurity. We do a lot of PC hardware and stuff. Oh, cool. That's good to know. Thank you very much. So Tuesdays we do PC hardware related content, and then Thursdays we do cybersecurity related content. If you guys have not caught up to this point yet, I definitely recommend you go ahead and check out the past few streams after this. It'll kind of piece everything together. Again, this is all beginner friendly, and I'm here to answer any questions anybody has, whether that's in the comments or in the live chat. So, we won't move too fast, but basically, we are learning a little bit about operating systems today. And when I say a little bit, that's undermining it because we're actually kind of doing a deep dive. We're going to get into, we're going to simplify them, of course, so that we understand what we're working with. And then after that, we're going to go ahead and go on TryHackMe, and we're going to open up the world of Linux, what it looks like to actually do a little bit of lab work when it comes to Linux. If you guys have been on the stream before, you know the structure of learning that TryHackMe has. It's really cool. It's really simple, and it does a lot of explaining along the way. Like we did a virtual security operations center one. We did one about advanced web searches and deductive searching on Google, and just all kinds of really cool things that are beginner friendly and you can kind of get your feet wet with. So we're going to proceed to that. But without further ado, I'm going to go ahead and share my screen. And we're going to go ahead and watch a short video on we're going to watch a short video on operating systems, and I'm going to explain it for you guys. And then after that, we'll move straight into TryHackMe, and we'll go ahead and get the labs going. Okay, so remember, these videos start abruptly. I don't know if you've seen this before, but this is every operating system explained in 8 minutes. So let me just go ahead and give you a background, right? I think they will, but just in case it doesn't, here's what I want you to know. The operating system is basically how you control all of your components working with each other, right? And the reason that we want to do that is because without that, your mouse would have no way to connect to your motherboard, and your, the signals of your BIOS would kind of, from what I understand, just like end up in a black hole, right? So you can't operate a system without an operating system. Sounds funny, but that's literally how it works. So there's many different operating systems that you can use. People only know of a few of them. The famous three are definitely going to be Windows, Mac OS, and Linux. Android is very famous also. That's a mobile device operating system, just like iOS is also. So iOS and Mac OS are same family. Windows, Android, same family. Linux, Unix, I believe same family. We're going to learn a little bit more about that. But anyways, the big three are Windows, Mac, and Linux. And then we have Chrome operating software, which I'm honestly new to. I don't know too much about it, so that's going to be interesting to learn. And BSD is something that I also don't know too much about. So if nobody has questions, we're going to go ahead and pop in, and I think he begins with Windows.
Windows. Windows is the most widely used operating system in the world, created by Microsoft. It was first released in 1985 as Windows 1.0. Originally, it was just a graphical interface running on top of MS-DOS. Everything looked very basic at first, but over time it evolved into a full-fledged operating system, with major versions like Windows 95, Windows XP, Windows 7, Windows 10, and now Windows 11. What makes Windows stand out is its versatility and widespread compatibility. Windows can run on almost any PC or any laptop brand, and it's capable of various computing purposes, from hardcore gaming to office work, and even programming as well. And Windows OS has a user-friendly interface, making it easy for beginners. However, Windows can be troublesome as well. Its hefty system requirements can make older or weaker hardware feel sluggish. It's also infamous for frequent updates, which, while meant to improve performance, often feels intrusive, and sometimes it can lead to an infinite Windows update loop. Security is another concern because...
So before he goes into security, I want to clarify something he said. He said hefty system requirements. Typically what he means, or not typically, but essentially what he means by that is Windows is an operating system that does require memory in both senses. It does use a lot of RAM to operate while you're using it. So it does use a lot of your random access memory. And then it also requires what most people would consider a significant amount of storage on your SSD device or whatever your boot device is going to be. So it's kind of a large file operating system, if you will. And those requirements can make things lag on older systems. So that should clarify what he said.
As Windows is the most widely used OS, it's also the biggest target for viruses and malware. And of course, there's the legendary blue screen of death. In fact, this problem has been around since Windows 1.0.
Classic, man. Horrible.
Mac OS. Mac OS was introduced in 2001 by Apple as the operating system for Mac computers. Unlike Windows, which runs on various brands of PCs, Mac OS is exclusive to Apple devices like MacBooks and iMacs. This tight control over hardware and software makes Mac OS extremely stable, smooth, and well optimized. It's especially popular among creative professionals, including video editors, graphic designers, and even musicians. It's all thanks to Apple's powerful built-in apps like Final Cut Pro, Logic Pro, and GarageBand. One of macOS's biggest advantages is that if you own an iPhone or iPad, macOS lets you sync messages, calls, and files seamlessly. Also, there are no frequent forced updates or crashes like Windows. And the battery can last longer as well. But despite the advantages, macOS has some downsides as well. Since it only works on Apple computers, users are forced to buy expensive Mac hardware, which can be a deal breaker for budget-conscious buyers.
macOS
Another major issue is gaming, because macOS devices don't have DirectX and powerful GPUs or graphics cards. Additionally, some professional software isn't available. If available, it's a limited version. Linux. Unlike Windows or macOS, Linux is not a single operating system, but a family of operating systems known as distro or distribution. It was created in 1991 by Linus Torvalds, a Finnish software engineer who wanted to make a free and open source alternative to the other operating systems. Unlike Windows, which needs high system requirements, or the expensive macOS devices, Linux is lightweight, secure, and doesn't require expensive hardware, which is why it can run on many older computers and high-performance servers. And
so it can kind of run on anything, which is why Linux is the #1 operating system for Internet of Things devices also.
Since it's open source, anyone can modify or build their own version of it, which is why there are many Linux distros. Some are designed for regular users, like Ubuntu and Fedora, while others are built for servers and professionals, like CentOS and Debian. This capability made Linux widely used for programming, cybersecurity, and server management. In fact, websites and some powerful computers of Google, Facebook, and even NASA's systems run on Linux servers. However, Linux is not beginner-friendly. Since it's very different from Windows and macOS, new users often struggle with its interface, especially because many Linux distros rely on text-based commands instead of graphical menus. Another issue is software compatibility. Most mainstream apps...
So that's the #1 thing, right? That actually had some great visual examples. I'll go ahead and expand it a little bit. Linux is not too pretty. So Um, it's not too pretty looking. Like this is basically
especially because many
this
Linux
right
distros
here
rely on text-based commands
is
instead of
like the
graphical
coding of
menus.
what that would look like. So this is like the clothing of what that
Another
code
issue is software compatibility.
Can get
Most
really
mainstream
tricky, man.
apps and games are built for Windows or Mac OS, so users need to find alternatives. So yeah, that's why people don't use Linux unless they're kind of experts. Chrome OS. Chrome OS was developed by Google and was first released in 2011 as a lightweight and cloud-based operating system. Unlike Windows or Mac OS, which rely on installing software directly onto a computer, Chrome OS is designed to work primarily with the internet, making it perfect for users who spend most of their time browsing, streaming, and
very
using web
vulnerable, I
apps.
can't lie.
It comes pre-installed on Chromebooks, which are affordable and fast laptops and suitable for schools and office work. Chrome OS also boots up in seconds and has automatic updates in the background. It is also highly secure because most tasks are handled and saved on Google servers rather than on the device itself, meaning there's less exposure to malware or system corruption. It also has access to the Google Play Store, allowing users to install Android apps, making it more versatile than a basic web browser. But Chrome OS has weaknesses as well. Since it's heavily internet dependent, it doesn't work well without an active connection. It also lacks support for many desktop applications, like full versions of Adobe Photoshop or professional video editing software. They're also not ideal for high-end gaming unless you use a cloud gaming service like GeForce Now, which depends on fast internet as well. Also, you can't do heavy multitasking too, like opening Photoshop while doing video editing is nearly impossible. Android. Android is an open source OS developed by Google and is the world's most popular mobile OS. It is used by multiple brands, including Samsung, Xiaomi, and many more. Something cool about Android is we can change themes, install third-party launchers, and customize almost every aspect of the system. Unlike iOS, which has a lockdown interface, it also has Google Play Store, which offers millions of apps and games. And Android allows you to find a variety of budget-friendly phones, as well as high-end flagship models with powerful specs. However, Android has some drawbacks. Not all devices get regular updates. This can lead to issues like slower performance over time and security risks on outdated devices. Another problem is bloatware, where manufacturers pre-install unnecessary apps that can't be removed. Also, while Android is powerful, it's generally less optimized than iOS, meaning that some apps can be laggy on Android, but smoother on iPhones. iOS. iOS was developed by Apple and is the operating system that powers iPhones and iPads.
This is probably what most of you guys are familiar with because the demographic of iPhone ownership is kind of crazy at this point. iOS is the thing that we've all kind of grown to love. I think that they've done an incredible job with the user interface specifically when it comes to iOS. Its capabilities are arguably behind that of the Android system, but the user interface and the overall experience that comes with the iOS operating system is very, very, very top tier, to say the least.
Unlike Android, which is open source and used by multiple brands, iOS is exclusive to Apple devices, giving Apple complete control over both the hardware and software. iOS devices are stable and have long-term software support. Even older iPhones receive updates for years. The App Store also offers a highly curated selection of apps, with many developers prioritizing iOS for new releases due to its higher security standards and paying user base. Additionally, the iOS ecosystem allows Apple devices like MacBooks, iPhones, iPads, and Apple Watches to connect seamlessly together. But iOS has its downsides. It is highly restrictive because users can't even customize their home screens as freely, install apps from outside the App Store, or easily transfer files without Apple's ecosystem. iPhones also lack expandable storage and a headphone jack, and iOS devices tend to be expensive, while Apple tends to reuse the same thing for multiple iPhone generations. Unix. Unix is one of the oldest operating systems and the one that gave birth to many modern operating systems. Originally developed in the late 1960s.
Whoa, hold on. We need to go back to this, bro. Okay, so Unix-like. Where is Linux at? Linux is like Unix. Okay, so they are similar, but not directly correlated in the same way that like Mac OS and iOS are. So let's learn a little bit more about Unix.
gave birth to many modern operating systems. Originally developed
That's
in the
great.
late 1960s at Bell Labs by AT&T, and it was designed as a multi-user, multitasking OS, mainly for servers and high-end computing. Unlike the
Oh,
popular
okay.
modern operating systems, Unix is rarely used by everyday consumers.
Yeah.
It's usually used to handle large workloads of big corporate servers, banking systems, and scientific research.
Okay.
For example, the National Weather Service uses Unix-based systems to manage and process massive amounts of meteorological data, which are essential for weather forecasting. By the way, Unix installation is very expensive at $1,407 for every user. This means that if you have a big company with 250 users, a full Unix
Whoa.
deployment would cost more than $350,000. BSD,
So
Berkeley Software Distribution, is
if it's used for things like that, it's probably extremely redundant. Like it's probably one of those things that can be relied on and applied to legacy systems very easily. So that's pretty cool.
family of operating systems that originated from Unix, developed at the University of California, Berkeley in the 1970s.
Wait, I'm sorry. I'm gonna go back because I kind of like talked and threw that off.
BSD, Berkeley Software Distribution, is a family of operating systems that originated from Unix, developed at the University of California, Berkeley in the 1970s. Unlike commercial operating systems, BSD is usually used by tech experts for servers, networking, and embedded systems rather than consumer laptops or desktops. Examples of BSD-based operating systems are PlayStation 4 and 5, Netflix's content delivery network, and also firewalls like PFSense and OPNsense. It's all because of BSD's efficient resource management and its ability to handle a lot of work. By the way, BSD has several versions, including FreeBSD, OpenBSD, and NetBSD.
Okay, so yeah, that's all the operating systems and kind of how they work, right? So we'll go ahead and go to TryHackMe now, because now you guys kind of know what Linux is, and we even learned a little bit about like where it came from. Like Unix is kind of the OG of Linux, right? So let's get on. Linux Fundamentals Part 1. So now that we know what it is, let's get into it and let's see what we can learn. I kind of command line networking. There's a lot of stuff to learn, man. I'm excited. All right, let's do it. Linux Fundamentals Part 1. It's the only time ever that my internet's slow when I'm trying to stream. Okay. Learning Linux Part 1.
Hey everyone, welcome back to another video here on TryHackMe. I am John, and today we're going to be taking a look at Linux Fundamentals Part 1. Embark on the journey of learning the fundamentals of Linux, learn to run some of the first essential commands on an interactive terminal. Now, if you have had very little experience with Linux, or maybe none at all, you're in the right place. Maybe the command line is kind of a spooky thing that, maybe you're not very comfortable with it. Or maybe you've had some practice and you want to polish things up and get additional practice to really solidify those Linux skills.
So I told you guys not to be intimidated. There is a platform where we can learn Linux, and you can start from the bare bones basics of what it is. Now, like if you took CompTIA A+, Core 1202 teaches you a couple Linux commands, the -R, the double dash, how to actually use these commands and what they do. So Linux is almost like you're writing code in order to do things. So you're gonna have to actually like know these commands and what the words that you're typing into the system are going to actually do as far as generating an action within that operating system. So welcome to the first part of Linux Fundamentals Room Series. I appreciate this video, and I would definitely watch it by myself. But because we're learning together, I think we're going to go ahead and go through this. I know enough about Linux to get started. I learned about it in the CompTIA Plus curriculum, and I've played around with Linux a little bit, so I have like the bare understanding of what it is and how it works. But I'm excited to get more into it. So it looks like we kind of have about 8 to 9 tasks. We have 8 tasks total, and then task 9 we'll probably do next week, part 2 next week, because Linux is something that is extremely important in not only cybersecurity, but just in the world of computers and networking and everything that we do and use and love. So I think it's really important to spend a little bit more time here than on other topics. And plus, like I said, this is something that I'm learning myself. So if you guys are not interested in Linux, come on, man, stick around. I guarantee you're going to learn something. Like, you can't know everything, right? Welcome to the first part of the Linux Fundamentals Room Series. You're most likely using a Windows or a Mac machine. Both are different in visual design and how they operate. Just like Windows, iOS, and macOS, Linux is just another operating system and one of the most popular in the world, powering smart cars, Android devices, supercomputers, home appliances, enterprise servers, and even more. We'll be covering some of the history behind Linux and then eventually starting your journey towards being a Linux wizard. Told you. This room will have so what we're going to do in this room is we're going to run our very first commands in an interactive Linux machine that's browser based. So this is like one step, one tier, one step, one level below, like downloading a virtual machine and then like using Ubuntu or something to actually use Linux as if it were your own bare bones operating system. This is browser based. So if you guys don't have the hardware resources that you can allocate towards making a virtual machine, which I'm going to do a full upload on to run you guys through the process of how to do that. Probably film it this weekend, so it should be coming out sooner than later. I don't want to put any timelines on it because I am busy with jewelry right now, and that has to take priority, of course. But here we go. We're going to teach you some essential commands used to interact with the file system. Okay, so it's a browser-based interactive Linux machine. And then we're going to demonstrate how you can search for files and introduce shell operators. Let's get started. A bit of background on Linux. Where is Linux used? It's fair to say that Linux is a lot more intimidating to approach than operating systems like Windows. Both variants have their own advantages and disadvantages. For example, Linux is considerably much more lightweight. You'd actually be surprised to know that there's a good chance you've used Linux in some other form on maybe another day. Linux powers things such as websites that you actually visit, car entertainment and control panels, point of sale systems such as checkout tills and registers in shops, and critical infrastructures such as traffic light controllers and industrial sensors. So remember, guys, I told you Linux is all around you. It is like the operating system of the world, essentially. Linux is actually an umbrella term for multiple operating systems that are Unix, that are based on Unix. So I'm glad we learned about Unix, and I taught you a little bit about it with that videos. Thanks to Linux being open source, variants of Linux come in all shapes and sizes, suited best for what the system is being used for. So there's kind of like different packages of it that you can use for different things, and they're tailored towards different use cases. Some are better than others, but it's just really down to what you want out of your system and what you're doing with it. So for example, Ubuntu, which is probably the most popular one, I think, and Debian are some of the most commonplace distributions of Linux because it is so extensible. You can run Ubuntu as a server, like websites and web applications, or as a fully fledged desktop. For this series, we're going to be getting ready. We're going to be using Ubuntu. No, Ubuntu servers can run on systems with only 512 megabytes of RAM. So in the last couple episodes, we talked about RAM. We did a deep dive on it. Remember that I was showing you guys like the sticks of RAM, and I was saying like the minimum you would ever want is like now 16 gigs maybe, but like 8 gigs is required to like run a system at all with any type of efficiency. We're talking about gigabytes, right? So that's with like running Windows operating system RAM. Megabytes of RAM is half of 1 gigabyte. So that's like You could run it with less, like a flash drive, like a 2 GB flash drive that you would use for school, like less memory than that is all you need to actually be able to run this operating system. Um, Similar to how you have different versions of Windows 7, 8, and 10. I really hope none of you guys are on Windows 7 or 8. There's arguments for why you should not be on 10 also, such as security patches. So definitely look into upgrading to Windows 11. You should not have any issues with it. And it's such an easy thing to do to make sure that your system is secure at home. So there's many different versions and distributions of Linux. So research, what was the first release of Linux operating system? What was the first release of a Linux operating system? Linux OS first year. We actually learned this in the video. So it was 1991, if you guys don't remember that key fact. But yeah, so Linus did it in 1991, right? Was his name Linus? Was his brother named Linus, or did I make that up because of Linus Tech Tips? Linus Torvalds. Nope, his name is Linus. There's multiple legendary Linuses. All right, cool. Let's move. Interacting with your first Linux machine in a browser. This room has a Ubuntu Linux machine that you can interact with within your browser while it's following along with the room's material. However, to get started, simply press the Start Machine button below. Once deployed, a card's going to appear at the top of the room. This is going to contain all of the information for the machine deployed in the room, including the IP address and expiry timer, along with buttons to manage the system. Remember to terminate a machine once you're done with the room. More information can be found in the tutorial room. For now, let's go ahead and press Start Machine, where we'll be able to interact with our own Linux machine within our browser while following along within this room. So don't get confused at what do I mean by the room. The room is this TryHackMe page that we're on, essentially. All right, so let's go ahead and start the machine. So compiling resources. This is cool, man. You guys should be able to do this with a basic system. It shouldn't take too much hardware resources to be able to run this with me, because again, this is browser based. I'm trying to keep what I do browser based for one specific reason, and that's because the more browser based it is, the more people can access it. Excuse me. I don't want to become a channel that is like doing things that are out of people's reach, because I want it to be a community where we learn together. So again, and I haven't even paid for this yet. I will if it requires me to. If it stops me and says, "Hey, you need to pay at a certain point," I'm more than happy to, because these labs are awesome and I'm learning a lot. So right here, we actually have our virtual like Ubuntu virtual boot up, right? Okay. All right. Deployed my first Linux machine. Okay. Yeah. Running our first few commands. Let's go. Yeah, that's fine. As we previously discussed, the large selling point of using operating systems such as Ubuntu is how lightweight they can be. This, of course, doesn't come without disadvantages, where, for example, there's often no GUI. GUI stands for graphical user interface, or what is known as the desktop environment that we can use to interact with the machine, unless it's been installed to do so. A large part of interacting with these systems is using the terminal. So it's using, taking the clothes off, or you're using the bare bones of it. The terminal is purely text based, and while it's intimidating at first, if we break down the commands after some time, you start to become familiar with using that specific terminal. Okay, so this is what our terminal looks like. This is our terminal right here. All right. We need to be able to do basic functions to be able to navigate to files. Okay, so this is what it looks like. Perfect. We've identified it. We need to be able to do basic functions like navigate to files, output their content, and make files. These commands to do so are self-explanatory once you know what they are, of course. Let's get started with the first two commands, which are broken down into this table below. So the first command that we can type is echo. Output any text that we provide. And who am I? Or wow me. It's who am I? Find out what user we're currently logged in as. See the snippets below for an example of being used. Okay. Echo. As shown in the system below, if we want to echo a single word, we don't need to use double quotes. For example, echo hello. However, the string should be enclosed within double quotes if one or more spaces are present. For example, who am I can be used to find the username we're logged in as. Okay, so let's give this a shot. Let's type in echo. Hello. Okay. I don't know why I did that. I don't really see the point of doing an echo, but all right, maybe it's just to test your interaction with it. Kind of like maybe it's like ping? I don't know. I'm not too sure. Okay. Who am I? I am TryHackMe. If we wanted to output the text, TryHackMe, what would our command be? Okay, so to output the text. Oh, okay, I got it. So echo is how we put our echo. Like we do it like that, right? Try hack me. And then our output command, because this is our input command. What is our output command? Comes out to try hack me, right? So echo try hack me. I don't know if it's caps sensitive, but okay, so it corrected it for you, but it looks like it is caps sensitive. What is the username of who you're logged in on as? I forgot how to read. I'm so sorry. What is the username of who you're logged in as on your deployed Linux machine? It's TryHackMe. I just asked. It's TryHackMe, dude. Yeah. Okay. So input, output. So our input was who am I? That tells us who we are. Input, TryHackMe, TryHackMe, hello. Okay. All right, cool. So we now understand basic input and output. Let's move on to the file system. So far, we've only covered the echo and who am I commands. Note that not all that useful when you consider things that we need to do, including navigating the file system and read and write to it as well. In this task, we're going to be learning the commands so we can do just that. Just like the previous task, I'll display the commands in the table in the next heading and show examples of these commands being used. As I previously stated, being able to navigate the machine you're logged into without relying on a desktop environment is pretty important. After all, what's the point of logging in if we can't go anywhere? So if you can log in and just you talk to yourself, I mean that's cool. Like I'm not judging you, but we want to do stuff with the system, right? So this command ls is for listing, cd is for change directory, cat concatenate, pwd, print the working directory. Before we can do anything such as finding out the contents of files or folders, we need to know what exists in the first place. So how do we find out what's there? This can be done using the ls command, which is short for listing. In the screenshot above, we'll see what there are some directories and folders. Okay. So what the command ls, then important files, my documents, notes, pictures, right? In the screenshot above, we can see that there are following. That's the following. Okay. You can probably take a guess as to what to expect a folder to contain given by its name. You can list the contents of a directory without having to navigate it by using the name of the directory. So ls pictures is like a little pro command. Should definitely be writing these down. I'm going to go back and write them down. If you guys are watching this whole video and you're actually going to watch it through, I think that's amazing and I commend you for it. Make sure you have your notebook and pencils and pens or whatever. Write down these commands. So remember the first ones, echo and who am I? And now we are moving on to interacting with the file system. Okay. So CD. Okay, let's keep reading. All right. So to changing our current directory, now that we know what folders exist, we need to use the cd command. All right, so let's do this. ls. Let's do it alongside. ls. We've got folder 1, folder 2, folder 3, and folder 4. Okay. All right. Now that we know what folders exist, we need to use the cd command to change to that directory. Say if I wanted to open the pictures directory, I would say cd pictures. So like, let's say we want to open folder 2. In this case, it looks like there are 4 pictures of dogs. In folder 2, there's money. Is that what I'm reading? Huh. Interesting. Oh, I don't know how to change directories. Yeah. Use ls to list available folders. Oh. Got it. Okay. Get out of here, bucko. All right. We're back. Well, listen. Okay. Okay. Now we know what folders exist. You use the cd command to change to that directory. So if you wanted to open the pictures directory, you would do cd pictures, kind of just like I just did. So I did cd folder 2, and yeah. Where again, we want to open the pictures. Where again, we find out the contents of the pictures directory. Where again, if we want to find out the content of the pictures directory, and to do so, we would list ls again. In this case. Oh. Okay. Let's see. cd folder 1. I typed it wrong. All right. Outputting the contents of a file. While knowing about the existence of files is great, it's not that useful unless we're able to actually view the contents of them. So we can know that these files exist, but we need to be able to actually do something with them. ls lets us know what files are available in the documents folder of this machine. So we've applied some knowledge earlier with this task. Used ls to see what's in the machine. To do cat to do text. You can use. Oh man, how many folders are there? There were 4. Which directory contains a file? Which directory contains a file? All right, so we got to check cd folder 3. All right, so that just kind of resets the machine, I guess. Let's try again. Let's try again from the top. Because this is a little bit confusing. I'm not going to lie. This is definitely a little bit confusing. So let's slow it down. Let's back up a little bit. Let's try to reabsorb the information from the top. Okay. All right. ls, cd, cat, and pwd are the commands that we're going to work with. So we're going to start from the top. We're going to do ls, right? What happens when we hit ls? It brings up our folders. Now, we know these folders exist. We need to use a cd command to change that directory. cd folder 4. Let's type in folder 4. Okay. What? Okay, that's what I was doing, bro. Leave me alone. Use ls to see what's in your directory. That's what I did. cd folder 3. Okay. Uh okay. So that's where I am. There's nothing in there. Okay. So man, hold on, man. Okay. Hold on. I'm stuck, bro. I don't know what to do. I'm stuck in folder 3. Help, dog. What do I do, bro? Okay. That's what I did. CD folder 4. Because it thinks I'm in the other one. We need to start over. Okay, ls cd folder 4 folder 4. We in there. We're in folder 4. And then in there we use ls. No. Oh, we found it. I got it. Okay, so it's in folder 4, and inside folder 4 there's something called note.txt. Okay. While it's knowing the file is okay. So wait. We'll come across tools that allows us to transfer file from one machine. We're going to talk about simply seeing the contents of text files using a command called CAT. CAT is short for concatenating, and it is a fantastic way for output the contents of files. In the screenshot below, you see how I've combined the use of ls to list the files within a folder within a directory called document. So he hit within the documents folder, he hit which brought him to that. So then, okay, so I want to see that. So I want to type in cat to do text. Oh, sorry. That's on theirs. I want to see cat note. You have to be very literal. You'll notice if you don't put in the right input, you don't get the right output. So input output extremely essential. Take your time when you're typing in these commands. Hello world. Okay. That was cool. Okay. Finding okay. Sometimes things like usernames, passwords, really, flags, or configuration settings are stored within files where cat can be used to retrieve these. Oh man. Finding out where the full path to your current working directory. You'll notice as you progress through your machine, the name of that directory that you're currently working in will be listing in your terminal. It's easy to lose track of where you are in the file system exactly, which is why I introduced PWD. Using the example of the machine before, we're currently in the documents folder, but this is exactly where is this exactly in the machine? We can figure this out. So where are we? We're in folder 4, but where is that? Okay. Cool. So it tells us where we are. So PWD is like a find your way feature. Like if you're stuck or you don't know which like folder you're in or what file you're actually in, you can PWD is going to tell you. We already know that we're in documents thanks to our terminal, but at this point we have no idea where documents are stored so that we can get back to it easily in the future. I use the PWD command to find the full file path of this documents folder. So that's the full file path. It's home, TryHackMe, folder 4. Um, cool. We're helpfully told by Linux that this documents directory is stored at home.ubuntu documents. It's great to know. Now, in the future, if we find ourselves in a different location, we can just use cd/home/ubuntu/documents to change our working directory to this documents directory. So you can go straight there. You don't have to do it the way that I did it. You can go straight there if you know where there is. Okay. Which directory contains a file? Folder 4 contained our file. The contents of the file. It was a text and it said, "Hello world." And we used the cd command /home TryHackMe folder 4. Cool. All right, so that's a little bit about paths and how to use your input and output system to actually open things. That was kind of cool, huh? So we're actually learning Linux, like for real. Like we just used our commands, and things are starting to make a little bit more sense now. Searching for files. Okay, although it doesn't seem like it so far, one of the redeeming features of Linux is how efficient you can be with it. Yeah, obviously. But with that being said, you can only be as efficient as you are familiar with it. As you interact with the operating systems like Ubuntu, essential commands like those we've already covered will start to become muscle memory. One fantastic way to show how efficient you can be with systems like this is using a set of commands to quickly search for files across the entire system that our user has access to. No need to consistently use cd and ls to find out what is where. Instead, we can use such commands such as find to automate things like this for us. Dude, I wish I knew that in the last lesson because that would have saved us time. But I guess that's why we do it piece by piece, right? This is where Linux starts to become a bit more intimidating to approach, but we'll break it down and ease you into it. Okay. This is where Linux starts to become a little bit more intimidating to approach, but we'll break it down and ease you into it. The find command is fantastic in the sense that it can be used both very simply or rather complex, depending upon what you want to do with it exactly. However, let's stick to the fundamentals first. Take the snippet below. We can see a list of directories available to us. We do ls, boomba, 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 boomba. Now, of course, directories can contain even more directories within them, which becomes a headache when we're having to look through every single one just to try and look for specific files. So we're going to use find. Let's start simple and assume that we already know the name of the file we're looking for, just can't remember where exactly it is in that pathway. In this case, we're looking for passwords.txt. If we remember the file name, we can simply use the find -name passwords text, where the command will look through every file folder in our current directory and file like so. Okay. All right. Seems simple enough. Find has managed to find the file. It turns out it's located there, but let's say we don't know the name of the file, or we want to just find things that have a text extension. We can do that too. We can simply use what's known as a wildcard, which is that asterisk, to search for anything that has .txt at the end. In our case, we want to find every text file that's in our current directory. We will construct a command such as find-name asterisk, aka wildcard, which is going to, again, search for anything that has a text at the end. So that's a more broad search. It's giving us the location of each one. Okay. Find has found that. That wasn't so tough. Okay, so grep, another great utility that we have to learn about is the use of grep. The grep command allows us to search the contents of files for specific values that we're looking for. Oh, take, for example, the access log of a web server. In this case, the access log of a web server has 244 entries. Using command like cat isn't going to cut it too well here. Let's say, for example, we wanted to search this log file to see for things in a certain user/IP address visited. Looking through 244 entries is not going to be very efficient, considering we got to find something very specific. We can use grep to search the entire contents of this file for any entries of the value that we're searching for. Going with the example of a web server's access log, we want to see everything that the IP address 81.143.211.90 has visited. Note that that's a fictional IP address. Do not try to DDoS it or do anything dumb. That's not mine. Sucker. I'm just playing, by the way. Obviously. Grep has searched through this file and will show us the entries of what we've provided. Okay. Searching recursively with graphs. I almost said reclusively. Very different words. Sometimes the information that we are looking for is spread across from multiple files inside a directory. Instead of checking each file, we can tell grep to search recursively through all the files in the subdirectory. To do this, all we got to do is use the -r, which is a recursive option. For example, to search for a variable across all files in the current directory and its subfolders, we can run grep-r pretty_name, etc. This is going to search every file in the current directory, search all subdirectories, and it's going to show where the pretty name appears. Your example output would be grep-r pretty name etc. Grep. Okay, so grep is a search tool. Basically, it's a combing tool to go through data. So use grep on access log to find the flag that has the prefix. Okay. So can we just do that? How do I? Still don't know how to like go back once you're in like once you're in a log, how do you get out of it? Because I was stuck in folder 4. That's something I need to figure out. Okay. Use grep on an access log to find the flag that has the prefix of THM. Huh? Hold on, let me figure it out first, bro. Hold on, let me figure it out. Let's go back to the top, remember? Using grep. Hmm. Okay, so it looks like we got to type that in exactly. Let's see what happens if we type in grep THM access log. What in the heck? All right. Something came up. What is the flag? What is the flag? What is a flag? What does it mean, bro? Did I miss that? Hmm. Oh. Oh man. So a capture the flag competition is like super Linux user. The entire contents of this thing. So I don't think I understand what it's asking me. What is the flag? What happens if I just type access log? That command is not recognized. Grep. I'm really not understanding this. Like, that's crazy. Hmm. I'm only gonna try this for 3 more minutes. If I don't get it by like 8:40, we're gonna move on, and I'm gonna practice this by myself. Um, yeah, because I'm not really understanding. Let's see, where are we? Okay. Um, to find the flag that has a prefix of THM. That has a prefix of THM? Oh, okay. It just clicked for some reason. That was a major brain fart. That's crazy. Okay, so it looks like it's get. I'm gonna caps lock it so it looks exactly like it would. Get access. What? We're like halfway done with the room too. That's crazy. So no, that doesn't fit. Hmm. I'm just gonna type this in. I don't understand how to find the flag, bro. I thought it was this. To find the flag, you use the grep command to search the contents of the access log. Grep THM. Where am I at? I don't know, bro. We're moving on. Yeah, I'm not. I can't stick there forever. I don't. Hmm. Okay. Well, let's move on. Linux operators are a fantastic way to power up your knowledge of working with Linux. There's a few important operators that are worth noting. We're going to cover the basics and break them down accordingly to bite sized chunks. At an overview, I'm going to be showcasing the following operators. This operator allows you to run commands in the background of your terminal. 2 ampersands. This operator allows you to combine multiple commands together in one line of the terminal. And this operator is a redirector, meaning that we can take the output from a command and direct it elsewhere. This operator does the same function. Okay, if we wanted to run a command in the background, what operator would we use? Lets you run a command in the background. Operator would be this one, ampersand. Just this single one though. So we understand that. All right. This operator allows you to combine commands together. This operator is a redirector. You can take the output from a command. This operator does the same function. The shell operator is a bit misleading. This operator is what's known as an output redirector. What this essentially means is that we take the output from a command we run. A great example of this is redirecting the echo man. Of course, running something such as echo howdy will return howdy. Of course, you can still just redirect howdy. Let's say we wanted to create a file named welcome with the message hey. Then we could create the file by doing that. Okay. If we wanted to replace the contents of a file named passwords with the word password 123, what would the command be? Hmm. Okay. So if we typed in echo content, oh no, you have to use these. That's the thing. These are part of the command. Content. And then forward. And then forward. No? Add an hour to stop it from terminating. Okay. We gotta add some time to our virtual like terminal. So I think that's pretty easy to do. Let's just extend the machine timer. Okay, so our machine is now updated with the new expiry timer. So I think it would be passwords, right? And then that, and then space, boom, space. And we want to change it to password. No? Nope. Okay, that's not it. Um, if you wanted to replace the contents of a file named password, this operator is also an output redirector. The content if we use sense to add hello, not hey, the operator. Okay. Hmm. Man, this is rough. I'm not understanding it. I am so bad at this, and it's okay to struggle, man. It's okay to take things slow and try to digest them, even if you're having trouble doing so. So I'm gonna give this a couple more minutes, and we're just gonna conclude it, man. I'm gonna stop it there. Um, I'm gonna practice like I should, and then hopefully next week I'll be a little more sufficient. If you guys have any resources for practicing Linux, learning Linux, things like that, definitely let me know. Yeah, because I didn't know a good portion of this, I would say I did not know. What happens if we type that in here? Huh? Linux is speaking Linux to me, and I don't speak Linux. Wait. Welcome. Hey, operator. This operator is also set. Hmm. Let's to append it. You gotta help me, Echo. You're the worst, bro. You don't really do nothing. What? Use LS to see what's in a directory. What now, Echo? What do I do now? This will show you all the files available in that directory. All right, I did. Then what? Hopefully, Echo's gonna walk us through this because I'm lost, bro. I would love for somebody in the chat to help me out. Now read the contents of the file in folder 4 to see what it contains. It just says hello world, but we know that. All right, we're gonna echo it. Boom. Echo that, echo. Echo me that, echo. Echo. Mm? What? Echo. If I wanted to replace the contents of a file named passwords with the word 123, what would my so echo this, replace that. This is weird, dude. Man, I love Windows and Mac OS and iOS and Android compared to this. Now, if I wanted to add TryHackMe to the if I wanted to add a TryHackMe to this file named passwords, but also keep passwords, what would it be? This is different. Rather than overriding contents, it just puts the output at the end. So would it be I wanted to add it. Okay, so I think it would be echo, right? TryHackMe double bobber to passwords. Okay. Yeah, I'm done with Linux for the night, buddy. Nice work on getting to this stage. We've covered a bit for your first interactions with Linux. Let's go back to searching for files and finish that one out. All right, Echo, do your worst. Dang it, Echo. I can guide you how to find it using the grep command. You can search for it. Okay. So let's restart it then. All right, grep. We're rerunning this. I'm sorry, guys. I didn't want to leave it. It's not working. Okay. You can search it in the access log file with grep thm. So grep thm. What am I looking for? I see an IP address. So we opened something, but I just don't know what in here is the flag, man. Gotta figure that out. So we're gonna pretend right now that tier 2 and 3 is closed and we cannot escalate this. We have to figure it out. You're looking for a specific flag that begins with THM. It's access. Use the grep command to search for that flag. This is what it brought up, bro. Shell operators made a little bit more sense, to be honest. It looks like you found the flag format in the access log. THM access. It's THM access, not get access. Oh my goodness. I just don't understand. I wasn't understanding how to read it. So THM access is the answer. Wow, 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 wow. Okay, let's go back. Oh my gosh, that took forever. Wow, okay. Well, that's what it was. It was this. And it was red in my face. Fantastic. All right. Well, at least we actually finished it now. All right, guys. Nice work on getting to this stage. We covered a lot for our first interactions with Linux. No, we really did. However, these are some of the most essential functions that you're going to be using when you interact with any Linux machine. So get to know your grep, get to know, all the things that we kind of struggled with together here live. Get to understand them and get to experience them. I think there's Linux classes on Udemy. Um, again, I don't think anybody can beat doing this. So come on, TryHackMe, do this yourself, read it out, experience it, typing in these commands. And then the next best thing would be to download a virtual machine, get Ubuntu on that virtual machine, and then try it on your actual computer yourself. That would be like the best way to practice it and what I'm going to do this weekend. So homework, get your VMs, practice with Ubuntu, right? So we covered quite a bit. These are the most essentials. I hope this room hasn't been too daunting for you to power on through with. As I mentioned before, you're going to become familiar with these things more quickly because of how often you're going to have to use them. To recap, we understand now why Linux is so commonplace today. We interacted with our first ever Linux machine. We ran some of the most fundamental commands. We had an introduction to navigating around the file systems and how we can use those commands like find and grep and to make finding data more efficient. Uh, we power up our commands by learning about some of the important shell operators. And we took some time to play around a little bit and really read and kind of digest things. When we feel a little bit more comfortable, we're going to progress onto Linux Fundamentals Part 2. All right. So, Linux Fundamentals Part 2 will be on Tuesday or Thursday. No, Tuesday is going to be hardware related. I think we're going to go ahead and discuss cooling. It's going to be a really cool episode. I'll teach you guys more about AIOs, how they work. We'll go on to a YouTube channel that does airflow tests. I'll show you guys how you can do one yourself. Yeah, so Tuesday is going to be really cool. We're going to discuss cooling up from the level of tiny fans or not tiny, but like, your average size fans that are spinning in my PC behind me to like entire immersion cooling and data center cooling and what that looks like. So definitely don't miss it. It's going to be a great episode. And then Thursday we'll do Linux Fundamentals Part 2. Once we get through Linux, then we're going to take a pause from labs and we're going to dive into IoT devices because I want to do a big section on that. I'm really interested in them. And I think that if people understood what IoT was, they would be more fascinated with everyday technology. So I'm excited to get into IoT, but I want us to understand Linux first. It'll all make sense later, I promise. So we have some time to play around in this room. Again, this is a great resource for you guys. Go ahead and practice your Linux stuff with. We can terminate our machine now. And terminate the machine. We did. Join Linux Fundamentals Part 2. This is where we hit the paywall, I think, guys. We'll see. If that's what it is, then that's what it is, man. More than happy to. Definitely more than happy to awesome. Yeah, this was really fun. Sure, man. All right. So that's it. That was our first little experience with Linux. We will go ahead and do Linux part 2 on Thursday. Tuesday, we're going to be discussing immersion cooling and AIOs and radiators and how systems are kept from basically exploding. So stay tuned. If you guys made it this far, I truly appreciate you rocking with me. I know this was a long one, and there were probably some spaces where there was just dead silence because I was focusing and really trying to figure things out. That's how it goes, man. I was trying to put myself in the mindset of like a tier 1 analyst or somebody who's working with a system that maybe doesn't have the opportunity to escalate this certain problem. So sometimes you just got to take a little bit more time to figure it out and use the resources that you have at hand. Luckily, one of the best resources that we had at hand was the AI from TryHackMe. It's kind of able to guide us through that lesson. So again, tryhackme.com, Lab King. If you guys know any other lab platforms that are browser based like this so that they don't consume a lot of resources, please go ahead and share them with us. And until I talk to you guys on Tuesday, have a fun, safe weekend. This has been Silicon Made Simple, beginner friendly tech YouTube channel where we break down hard to understand concepts and make them easy to understand so that you guys can enjoy them. I'm still working on that ending part. I'm sure you could tell because it changes every week. But whatever, man. That's all I got for you guys. Until next time, cheers.